The universe is a vast and dynamic expanse, brimming with secrets waiting to be unveiled. One of the most enigmatic and energetic forms of radiation emanating from the cosmos is gamma rays. To decipher the mysteries hidden within these high-energy photons, scientists launched Integral, the International Gamma-Ray Astrophysics Laboratory. Integral represents a collaborative effort between multiple space agencies and institutions, and it has been instrumental in transforming our understanding of the universe through its gamma-ray observations. Integral emerged as a response to the growing need for a gamma-ray observatory capable of studying celestial objects and phenomena in unprecedented detail. In 1993, the European Space Agency, ESA, approved the project as part of its Horizon 2000 program. A partnership of more than 20 countries came together to build, launch, and operate this sophisticated spacecraft. Integral's primary objective was clear: to observe and study gamma-ray emissions from a wide range of astronomical sources, including black holes, neutron stars, supernovae, and active galactic nuclei. Additionally, Integral aimed to investigate the distribution of radioactive elements in our galaxy, analyze cosmic ray interactions, and contribute to our understanding of fundamental physics. The heart of the Integral mission is the spacecraft itself, a state-of-the-art observatory equipped with an array of instruments designed to detect, measure, and analyze gamma-ray emissions from celestial sources. The spacecraft was launched on October 17, 2002, and it has been continuously monitoring the universe ever since. Integral's payload consists of 4 primary instruments, each serving a unique purpose. IVIS is a gamma-ray imager that provides high-resolution images of the gamma-ray sky. It can detect gamma rays with energies ranging from 15 keV to 10 MeV. IVIS has played a crucial role in mapping the distribution of gamma-ray sources and capturing images of gamma-ray bursts, GRBs, and other high-energy phenomena. SPI is a gamma-ray spectrometer capable of measuring the energy of incoming gamma rays with exceptional precision. It has enabled scientists to study the spectral properties of gamma-ray sources, helping to identify their origins and physical processes. While primarily designed to detect X-rays, JEMX also contributes to gamma-ray observations by providing additional information on the same sources. It covers the energy range from 3 to 35 keV and complements the other instruments by observing lower energy X-ray and gamma-ray emissions. OMC is not a gamma-ray instrument, but rather an optical camera. It is used to capture images of the celestial objects that emit gamma rays. These optical images are essential for correlating gamma-ray data with visible light observations, aiding in the identification and characterization of gamma-ray sources. Integral has made numerous groundbreaking discoveries and advancements in the field of gamma-ray astrophysics since its launch. Integral has played a crucial role in the study of gamma-ray bursts, GRBs, the most energetic explosions in the universe. It has detected and observed a multitude of GRBs, shedding light on their origins, properties, and impact on the cosmos. Integral's observations have provided valuable insights into the behavior of black holes and neutron stars. It has detected X-ray and gamma-ray emissions from these exotic objects, allowing scientists to probe their accretion processes and magnetic fields. Integral has contributed significantly to nuclear astrophysics by mapping the distribution of radioactive isotopes in our galaxy. These observations have enhanced our understanding of nucleosynthesis processes in stars and the distribution of elements throughout the cosmos. The spacecraft has extensively studied the region around the Milky Way's galactic center, uncovering high-energy phenomena such as X-ray binaries and microquasars, and contributing to our knowledge of the galactic environment. Integral has been instrumental in verifying predictions of fundamental physics, including testing the equivalence principle and the search for dark matter particles through their potential annihilation signals. As Integral continues its mission, it remains a vital asset in the field of gamma-ray astrophysics. The wealth of data it continues to gather holds the promise of further scientific breakthroughs and the potential discovery of new, previously unknown phenomena. Moreover, Integral collaborates with other space-based observatories and ground-based telescopes to facilitate multi-wavelength observations, allowing scientists to gain a more comprehensive understanding of the universe's most energetic processes. Integral, the International Gamma-Ray Astrophysics Laboratory, has made significant contributions to our understanding of the universe by unlocking the mysteries of gamma-ray emissions. Through its precise instruments and continuous observations, Integral has provided insights into gamma-ray bursts, black holes, neutron stars, and the nuclear processes shaping our galaxy. As the mission continues to operate, its legacy endures, promising further revelations about the cosmos and the fundamental physics that govern it. Integral stands as a testament to international collaboration in the pursuit of scientific knowledge, serving as a beacon of exploration and discovery in the ever-expanding realm of astrophysics. With its unwavering gaze into the gamma-ray sky, Integral continues to inspire scientists and space enthusiasts alike, reminding us of the boundless mysteries that await our exploration. And that's all for today. Hope you liked the video. Stay connected to get more knowledge about the space. Please like, share, and subscribe to our channel.